Okay, so on this one, what we need to do is take a look at the region we're talking about. So the graph of 4 minus x squared would be the parabola, and we're going counterclockwise around here. That's the line integral. Not particularly wanting to do two line integrals, we'll try to apply Green's theorem. Green's theorem says we should be able to do this by doing a double integral over the appropriate region, that being the region enclosed here, of q sub x, p sub y, described appropriately. Okay, so here is our p and q, and so the derivative of q with respect to x would come out to be a 1. The derivative of p with respect to y would come out to be a 2x. So our integral would come out to be a 1 minus 2x. And describing this region, like we did in an earlier chapter, we'll let y's go from 0 to 4 minus x squared, and x's from negative 2 to positive 2. So we're doing our y's first, from 0 up to the parabola, 4 minus x squared, x's from negative 2 to positive 2, and that appropriately describes the region. So now it's just a matter of doing that integral, which, being lazy like we are, we just take out our TI-89, and that comes out to be a 32 thirds. Well, let's take a look at another one. Now here we're given our vector field and our curve, and we're told to use Green's theorem to compute the work done by the force field. So the work done by the force field is going to be the integral around the curve of f dot dr. Now our curve, the ellipse, being 4x squared plus y squared equals 4, means that we've got a x squared over 1 and a y squared over 4 equals 1. So we can see that we're going to have an ellipse. In the x direction it goes 1 unit, in the y direction it goes 2 units. So this is the ellipse that we're talking about traversing in the counterclockwise direction. To use Green's theorem, we've got our p, which is here, 3y minus 4x, and q, which is here, 4x minus y. So the derivative of p with respect to y would come out to be a 3. The derivative of q with respect to x would come out to be a 4. And so our integral is going to simply have a 4 minus 3, or 1. And we need to describe our region. Well, now since this is a 1, notice that basically our answer is going to be the area of this ellipse. It would simplify matters quite a bit if we knew the formula for an area of an ellipse. But I won't tell you that. We'll go ahead and do it the calculus way. And the calculus way is this. We'll split this thing in two, do the top half. The top half, according to this, y squared is 4 minus x squared, 4 minus 4x squared. And y then would be plus or minus the square root of 4 minus 4x squared. since we're talking about, we're going to do the top half of this and double it. So our integral is going to be a double, and our y's are going to be going from 0 and the square root of 4 minus 4x squared. And then I make our x's going from -1 to +1. Type that into our calculator when we get to this point. And that comes out to be a 2 pi.